Hello everyone, good afternoon. Dear authors and invited guests, welcome to the technical session 9A. Myself Siddhi Auti and I'll be your session moderator for today's session. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD. The 10th edition of the conference is being organized in hybrid mode. The physical event is being held today in Goa, and the virtual event is being held via Zoom meeting from 17 to 19 July. I hope you all will enjoy this knowledgeable and interactive session. In this session, we will be having in total 10 presentations. Each presenter will be given a time span of 8 minutes for the presentation and 2 minutes for question and answers. After 7 minutes, I will be raising a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or face any issue, you can write it to me in the chat box. Now, just before we get started with the session, I would like to introduce you all to Dr. Sopan Tadekar, today's session chair. Dr. Sopan Tadekar is currently working as an associate professor in Department of Computer Engineering and Head Information Technology. He is Karamveer Advocate Baburao Ganpatrao Thakre College of Engineering. He has published and presented more than 10 papers in reputed journals like IEEE, ACM, and Springer. He has published two books on artificial intelligence for Pune University and Gujarat Technological University. I welcome Dr. Sopan Tadekar for chairing today's session. Now, without any further ado, we will get started with the first presenter. So the very first presenter we have here today is Kavya Soni from Manipal University, Jaipur. And the paper title is A Comparative GIS-Based Model Sensing Framework for Surface Water Quality. I request Kavya, sir, to please start with your presentation.
Hello.
Hello.
Hi. Can I share the screen?
Yes, sir, sure. You can share your screen now.
Okay, 1 second. There's some error. I'll have to leave and join the meeting again. So can you please give me 2 minutes?
Yes, sir, sure. You can just rejoin again and then share your screen.
Is my screen visible?
Yes, it is.
Yes, it is.
So good afternoon, everyone. It's really an honor to be here. So my name is Kavya Soni and I'm from Manipal University, Jaipur. And today I'm really excited to share you with one of my projects, a comparative GIS-based remote sensing framework for water quality monitoring. 1 second, what's the issue? Okay. So as we all know that clean water is vital, not just for human survival, but also for our entire ecosystem. So yet traditional ways of water quality measurement are expensive, slow, and don't give us the big picture. So that's why in this review, we explored a GIS-based remote sensing framework that brings together satellite imagery, spatial analytics, and machine learning. So the goal is to monitor key water quality parameters like turbidity, chlorophyll, and total suspended solids, which are optically visible from space and in a way that is scalable and real time. So by comparing various models, machine learning techniques and models, integrating them with by collecting the data from various satellites, we can evaluate how well they help us make better, more informed decisions about water management. So the good news is that we have already seen promising progress in remote sensing. Satellites can detect parameters, optically visible parameters like chlorophyll very easily. So long-term data from sensors like Landsat have even helped tracking how climate change affects water bodies. On the top of that, combining machine learning with remote sensing has shown to increase accuracy, while emerging trends like IoT and cloud-based systems make monitoring faster and more scalable. So here's the challenge we face today. The water quality data we have is often fragmented, outdated, and inconsistent across regions. So there is no standard framework to how to compare and validate satellite-based models effectively. So this creates a big hurdle for reliable monitoring and decision making. And there are even few bottlenecks present. So some of them are inconsistent satellite data, limited ground truth data for validation, and the algorithms designed are often highly sensitive for regional differences. So now let's discuss about the research gaps present. So the first gap, so the first research gap is the temporal gap in satellite data. So the satellite basically captures the data by rotating, by revolving across the Earth. So for example, let's take Sentinel-2. So it takes around 5 to 10 days to pass over a particular region. So if there is any pollution event which occurred in a particular water body occurring in its path, and it basically mostly pollution events last 48 hours, and so it might get undetected due to the low visiting rate of the satellite, so due to which the short term events might get skipped. So this is a gap which mainly affects the real time monitoring. And the second issue is the model transferability issue. So models trained in one region may not generalize to another, because the ecosystem and the amount of parameters present in water vary region to region. And so if we train a particular model to like develop relate to bring like to predict relationship between various parameters and accessing water quality parameters, so this might get affected if we try the same model on different data set. And the second one is sparse ground truth data. So like the water bodies are vast. So for example, if there is a water body which has an area of around 500 square kilometers, and if there are only two like sampling stations, then the data would be less, and this affects the the data availability also. And so let's talk about the methodology. So we approached this literature survey by systematically viewing various research papers published between the years of 2012 and 24. So we mainly focused on the research paper which worked using the satellite imagery or band data using satellites like Landsat 8, Sentinel-2, and MERIS. So we examined both machine learning and statistical models and evaluated them on the metrics like R2 score and RMSE. We also paid attention to various geographical scopes and data limitations and model transferability issues. So these are the key parameters which we have reviewed. So the first parameter is chlorophyll. So chlorophyll indicates the algal biomass in a particular water source. And it also tells us about the eutrophication levels. Turbidity, it tells us the sedimentation or particulate matter present in the water. Total suspended solids, it tells us the suspended particles, the concentration of suspended particles in a water source. Dissolved oxygen, it indicates water's ability to support life. Chemical oxygen demand, it tells us organic pollutants in the water. And pH, it indicates whether water is acidic, basic, or like affecting the aquatic health. And the techniques which reviewed were like mainly machine learning algorithm, various machine learning and deep learning techniques like random forest, support vector regression, artificial neural networks, principal component analysis, and linear regression, and qubit regression. So these all algorithms are built in such a way that they can easily in a way that they can like easily capture the complex patterns from a particular data set, or like the data we have, and they also work well when we have less data. So these are the key like main techniques which we have accessed on. So now let's get a brief about some of the most like significant papers which we have analyzed. So the first one is the
Hello.
retrieval of water.
So
Hello.
sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Okay. Yeah. So, like in conclusion, the GIS-based water quality monitoring has a great potential as a robust, scalable tool. By blending satellite data and spectral indices and advanced models, we can achieve more accurate assessments. However, like there are many fields for improvement in this particular field to ensure that model work across regions and there are also real time. There are some issues for implementing the real time integration of the, but there are few future research topics which we should focus on. So like some of our like integrating real-time IoT and with satellite observation, expanding studies to cover more diverse regions and seasons, and developing lightweight and edge-enabled models for remote areas, and we can also create open platforms for people who are interested or might want to research on water quality. So we can also build a platform for public through which these parameters can be accessed easily. So thank you so much. This was my presentation, and I will be happy if anyone would ask any questions.
Yes, Kavya, just can you show me the results analysis? That slide is keep, I think.
Yes, sir. So these are so this is a like table in which we have like there are a few parameter, like we have parameter wise taken, like as we can see, this is chlorophyll A, and these are the various machine learning algorithms applied on them.
Right. So different methods that were used by considering the different parameters, right?
Yes, sir.
So in terms of the accuracy parameter, which method that performs the better?
Sir, actually, it varies like from dataset to dataset normally, but like in this scenario, as we can see, the principal component analysis performed better, gave us a good R2 score, which is a great measure for particular chlorophyll. Like we can't build a generalized model which can tell us accuracy of, like, which can accurately predict all the parameters. We'll have to build model for different parameters which we want to
So,
work upon.
so in this, consider the more than one parameters or single parameters, so it is get
These
performed.
all are done on single parameters. For example, like in the first one, so this was entirely done on chlorophyll, and
Okay.
and when this particular model was tried on another parameter, it didn't perform well. But they might, like, after hyperparameter tuning, it worked well. So that was.
So this is all of you that you have done the literature survey, right?
Yes, sir.
There is no any your method is used to explore the things, right?
No, sir.
So
Sir,
what
actually, this is a survey paper.
survey people, right?
Yes, sir.
Okay. So you have mentioned your future scope. Then after survey, what you are going to conclude it?
What, sir? Can you please repeat?
Yeah, after this survey, what you are going to conclude it then? After this comparative analysis, what you are going to conclude it, and what will be the methodology that will be used in future?
Yes, sir. So basically, after reviewing all the research papers which I read, so sir, I have found that there are, in most of them, there is similar limitation, which is data, which is like in ground truth data, and like main problem is data collection. So we have like we have satellites, right? So we have great amount of satellite data, but the in situ data is limited. Because it's pretty expensive, and these are done in like in long intervals of time. So the main problem issue is data. So if in future someone wants to build a great model, or want to do research on this particular topic, I think it would take time. I think it would easily take 1 year of time for collecting great data set from great in situ like ground truth data set for building better classifiers or regression based models for this. So it would be like thorough data collection, which would be like more inclined with the time and latitude when the satellite passes over a particular station or a spot. So after, if that was done, then I think more better models could be built.
Okay. 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 Yes.
Thank you, sir.
Thank you, sir, for your presentation. Now we'll go on to the next presenter. So the next presenter is Riju Sundar from Rajalakshmi Engineering College. And the paper title is AI and AR-based integrated solution for optimal sericulture management. Sir, if you're present in the meeting or if any of the co-authors are present, please start with your presentation. I think he has not yet joined the meeting. We can proceed with the next one. Then later on, we can have his presentation. The next presenter is Gitanjali Popat Rokde from Pimpri Chinchwad College of Engineering. Ma'am, if you're there in the meeting, please give me a response. Or any of the co-author.
Hello, am I audible?
Hello? Yes, ma'am.
Yeah.
Ma'am, you can start with the presentation now.
Yeah. Wait a minute, I just share my screen.
Hello?
Is it visible? My screen is visible?
Yes, ma'am.
Okay.
Ma'am, you can start with your presentation now.
I think at my side, I'm not too.
Hello?
Hello.
Yes, ma'am.
I think there is an issue at my side.
Ma'am, we can see your PPT and even your voice is audible, so you can start with the presentation. What is the issue, ma'am? Hello?
Yes.
Ma'am, are
Hello.
you able to hear us?
Yes, yes, yes.
Ma'am, please start with your
Actually, the
presentation now.
sharing issue is there. I couldn't see my PPT on my screen.
Ma'am, we can see the PPT that you're changing slides and everything. We are on the index slide. So you can just open the presentation in your in some other tab and start presenting.
Okay, okay, no issue. Okay, good afternoon all. My name is Gitanjali Ropde and I'm giving this presentation under the guidance of Dr. Sonali Patel ma'am. My topic is an iterative statistical analytical review of blockchain-based federated learning consensus mechanism for real-time deployment. My contents are abstract introduction, literature review, research gap methodology, then result and discussion, comparative analysis, contribution, future scope, and references. So in abstract, federated learning enables collaborative model training across devices while maintaining the privacy. So in this paper, I have worked on those two different technologies like federated learning and blockchain technology. So federated learning basically is a collaborative learning. It's a machine learning technique. So it provides a multiple devices or entities collaboratively train the model without exchanging their raw data. And uh, it has a traditional way, but there is an issue with a centralized data set. And because of this, that the security issue is there. So for that, we are using the blockchain technology to provide the transparency and the security to that federated learning. For this, we have studied 25 blockchain-based federated models, which are focusing on security, efficiency, incentive, fairness, and scalability. First, scalability, then introduction. Um, so, uh, sorry. So federated learning is it avoids the raw data transfer. So basically, it trains the model at locally, and only the parameter or the model updates were exchanged to the global data centers. So there is a challenge uh, as a centralized aggregated failure or data leak or data poisoning at the time of exchanging the data from local to the global model updates. Then blockchain-based federated in integration with the blockchain-based federated learning, uh, um, blockchain provide the immutable, transparent updates and decentralized control and trust consensus. So basically, I'm focusing on the federated plus blockchain-based consensus. So and the focus is only the we are so the focus is only a healthcare scenario like electronic healthcare records. Uh, then the next slide is literature review. So I have studied mostly 40 plus papers for that. And through that, some consensus I have finalized. So proof of contribution, Byzantine false tolerance, proof of accuracy, proof of DAG, is directory cyclic graph based blockchain and federated learning model. Then multi-center federated learning model. So through these models, we are focusing on privacy, fairness, throughput, and real-time feasibility of that model. So uh, next slide. Please. So through this literature survey, I have used Prisma finding for that. So out of 40 papers, I have finalized 25 papers for uh, to check the accuracy and I have find out the key features to that. Um, so in first paper, blockchain based federated learning, the accuracy of that paper is 89%, and the key features high security. It provides a high security and moderate conversion. In second paper, I have studied that the context aware proof of contributions. In that, the accuracy is 92% and fairness. Its key points is fairness and prevent the lazy claims. So in third paper, long-term proof of contributions. In that, the accuracy is 91% and the key features is stable incentive reduce consensus time. So like that, I have studied the 25 papers, and through that the accuracy we have find the what papers accuracy is better and the efficiency is better, and through that the what are the key
Ma'am,
features of the
uh,
paper.
ma'am, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion part?
Okay. So the conclusion is that the federated plus federated blockchain-based federated learning provide the trustworthy, private, and secure federated learning system for healthcare. So I'm basically focusing on healthcare. So have only focusing on healthcare. And through this, the best model is a proof of accuracy for diagnostic accuracy checking, then multi-center proof of federated learning for collaborative hospital networks, and the Benzetite fault tolerance for high security model IoT. So futures direction for this is lightweight and quantum safe cryptography. We can, for quantum cryptography, we can use this. And second is the sharded consensus mechanism. So the data is in the group, and through that voting or consensus, we can for that we can use the federated based blockchain learning techniques and the real-time validation in healthcare environment. So these are the future scope and the conclusion. So if anyone wants to ask any questions, thank you so much.
Thank you, ma'am, for your presentation. If there aren't any questions, we can go on to the next presenter.
Ma'am, actually, what is the role of blockchain in enhancing the security and trustworthiness of federated learning system in real-time application?
So actually, federated learning is decentralized network. So at local end, the data is trained and the model gets updated, and globally they aggregated. So there, some issues or some attacks maybe happen. So to provide the security to that models, we are using a blockchain technology because it is immutable in nature and distributed and decentralized in way. So that's why we are using blockchain technology. And this is the review-based paper, this literature-based paper.
Okay, ma'am.
Thank you, ma'am. Now we will go on to the next one.
Thank you. Thank you so much.
So the next presentation is by P.R. Mahadevan from Amrita Vishwa Vidyapeetham. Analyzing DEI initiatives in ITES organizations, a comparative study of organizational disclosures and employee perspectives. Sir, please start with your presentation. Sir, if you are there in the meeting, please give us a response. Or any other co-authors.
Hello.
Yes.
Hello. Am I,
Hello.
am, am I audible?
Yes, sir, you're audible. Sir, can I know your name? You have
Hello.
joined with some other name.
Hello.
Hello.
Yeah, am I audible?
Yes, sir, you're audible.
Okay.
Sir,
Okay.
please start with
Good
your
afternoon.
presentation.
Okay. Good afternoon. Myself Mahadevan, and I'm from Amda School of Business, Kochi. And this is our topic: analyzing diversity, equity, and inclusion initiatives of ITS organization through organization disclosure and employee perspective. So, next slide. Hello. Next slide, please. So these are our co-authors, Bhadra R, Parvati NP, and Asil Mahadevan, and the faculty guide Pandra M. So diversity inclusion have emerged as a critical element in shaping the workplace culture and the performance of organization worldwide. We know that the DEI initiatives in various organizations became very much it became a very heated debate. So we know that various organizations have introduced DA initiative, but not up to that level. So the initiatives not only reflect an organization commitment to social responsibility, but also it's a catalyst for innovation and collaboration. And this is our reference. Just click on that reference. Uh,
Hello.
yeah.
Sir, is there an issue?
Um, okay, we can go with the next slide.
Sir, if you're facing any issue with the presentation, when you are in a stable internet connection,
Yeah,
you can
I am
share
facing
it.
some issue with it.
We can have your presentation after some time. Meanwhile, we will just continue with other presenters. Until then, you'll get some time to fix the internet issue. Is that all right? Hello.
Yeah, that's fine. Okay.
Okay, so we will go on to the next presenter then.
Yeah, am I audible? Yeah.
Yes. So the next presenter is Suhana R from Dayananda Sagar University, India, and the paper title is Bridging Career Gaps Using AI-Driven Career Pathways and Engaging Augmented Reality Simulations. So anyone, any of the authors or co-author from Sohana's group, if you're present, please start with your presentation and give us a response. I think no one is there from our group. So, moving forward to the next presenter, Janwale Asaram Panduranga from Sri Balaji University. And the paper title is Deep Learning Based Classification of Spine X-ray Images Using Attention Mechanisms. Sir, you're there in the meeting, right? Please start with your presentation. Hello.
Hello, am I audible?
Yes, sir. Sir, please start with your presentation.
Yes. Uh, Good afternoon, everyone. Myself, Zanole Asaram from Sri Balaji University. My research paper I'm going to present here, that is deep learning based classification of spine X-ray images using attention mechanism. So this is actually introduction. This study actually explores the use of deep learning models enhanced with the attention mechanism to classify the spine X-ray images that are normal images, normal X-ray images, scoliosis, then spondylosis categories. These are the three categories of spine disorders. So I am going to here classify these uh, by using the X-ray images. So depending on this the study, the references I use here, the classical methods or traditional methods that evaluate the X-ray images, including manual as well as some uh, machine learning based mechanisms are also available. But uh, I use here some CNN architectures like exceptions, inceptions, V3 and DenseNet, along with the attention mechanism to increase the accuracy of classification or multi-class classification here. So I am using here AI and deep learning techniques. So existing work that we have used here, that is using the deep learning architectures uh, along with the other mechanisms. So, but attention mechanism, that is including self attention and special attention, have improved the model of model accuracy here. So expected outcomes from this study is increasing diagnostic accuracy, then better interpretation, and develop AI tools to assist radiologists and clinicals efficiency. So the methodology used here, firstly, I prepare the data set and pre-process it. I, uh, I have taken the data set from the different hospitals, different radiologists, near about 1,338 spine X-ray images I have collected and labeled as normal, scoliosis, and spondylosis. This class imbalance was addressed by using oversampling and data augmentation techniques. So I use here rotation, cropping, and contrast adjustment to avoid the class imbalance. And then the image was resized to 224 by 224 pixels and normalized for model input. Then after the data set was splitted into the three categories, the training, validation, and testing. I use here 80, 10%. For training, I use here 80% images. Then for validation, 10% images, and testing, 10% images. Uh, so the model architecture, actually here, the different study was used here to classify these X-ray images. So exception, inception, and dense net techniques were already used here. But what I did here, I added one attention. I used these mechanisms with the attention layers to highlight the diagnostic, the X-ray images, and that will that is used to increase the accuracy of classification. So actually, why I use here attention, that helps the models to focus only on important regions like vertebral alignments, spine curves. So that will be mostly useful to classify and to identify these images. So that is actually why I use here attention mechanism. And the result which I got the accuracy I got the best here, and for that I use the training parameters here. So these training parameters were used to optimize the combined deep learning models. The Adam optimizer with uh, 0.01 accurate learning rate, and category cross entropy was suitable for multi-class classifications. And epoch I use here, at the 50th epoch, I get the best results here. So that was the training model I use. So what are the results here? How the model perform here? So as you can see here, the inception model gives the most accuracy here. That is about near about 97.40%. Than the this is more than the exception and dense net models. So if I use here attention mechanism, that proves here if I use the attention mechanism with inception V3, so that gives the very good accuracy here. So these are the confusion matrix that will be used here. And that shows the inception V3 flawless classification across the categories, raising outfitting concerns. So inception model is mostly useful here, and also use these heat maps uh, to prove this accuracy and these things. So then finally, I conclude here, integrating attention mechanism with CNN that it significantly improves the spine X-ray classification accuracy and interpretation. The inception model achieved here 97.40% accuracy. That is demonstrating the potential for clinical applications. Though the further, actually, some validations might be needed here, but if you want to use actually in the um, uh, for the clinical activities. So that is about my conclusion. Thank you. Thank you.
Thank you, sir, for your presentation. Are there any questions or shall I proceed further?
Hello.
Hello.
Yeah, I'm audible. Yeah.
Yes.
Yes. Just tell me the main advantages of using deep learning for the automated spine X-ray classification. If we compare your deep learning methods with the traditional image analysis methods, how actually it is going to improve the performance of it?
Sir, if we use the differently these models, so the what I got the result, these are very less accurately, and some of the models are also not useful to handle the overfitting sampling and all these things. So when I use this attention mechanism along with this CNN, so that gives me the best accuracy. As I told you, some validations are also required for to achieve uh, to use it practically. So that's actually we can say that advantage of this mechanism.
Okay, in such case, then how attention mechanism that improves the performance of deep learning models in classifying such as spine X-ray images?
Yeah, just so I just proved here the near about 97.40% along with if I use it with along inception V3, so I got the result near about 97.40% accuracy.
Okay. Okay, thank you.
Thank you.
So the next presenter is Yogesh Sabre from GH Raisoni College of Engineering and Management. And the paper title is Empowering EV Sustainability in Decentralized Energy Environment. Sir, I request you to please start with your presentation.
Yeah, are you able to see my presentation?
Yes, sir.
Okay. So, good afternoon, the session chair, Dr. Talekar sir, my guides, Rajesh Kumar Kashyap and Sagar Satpute sir, and everyone. My topic is empowering EV sustainability in decentralized energy environment. So, I just start with the introduction directly. So, microgrid is a concept wherein, microgrid is a limited scale energy framework that might run independently from or close by the bigger power network. So this is basically related to the electrical power networks and the sustainability part of it, taking into consideration the electric vehicles. So it is comprised of a microgrids are comprised of a group of circulatory energy assets, including batteries, solar-based chargers, wind turbines, and CHPs with the different capacity equipments. So its ability to disconnect from the principal, that is the main power grid. So microgrids are able to operate isolatedly from the power grid networks, and it runs freely on the making it a minimal energy organization. Microgrid can keep on giving power to the connected burdens. That is, burden is the load. So whatever connected equipments are there, they are able to give power to the different things by utilizing power from solar system, wind, and the batteries. So with the rise of the electric vehicles and the shift to greener transportation, this is going to be a very important part of the power system. It is estimated that the microgrid will keep on being broadly utilized in different areas, including private business, modern military, and far-off areas. So we can have microgrid at any level. So it is a small network which can be installed with the help of solar, wind, and your batteries using EVs to an island also, irrespective of whether you're getting power from main power grid or no. So microgrids are actually a sustainable power sources, including sun-based, wind, and hydropower things. So we'll start with the literature review directly, sir, to save on time, if you permit. So I've gone through, this is a survey paper basically. I've gone through almost 15 papers, more than that, but 15 are very related papers, which talks about the microgrids and its usage and EVs considered. So microgrids can help reduce carbon footprints, which is very, very important in sustainability from sustainability point of view, taking into consideration the rise of the CO2 and carbon footprints across the globe, and advance environmental sustainability by depending on the clean and renewable energy sources. The second paper was on the energy independence. So by utilizing renewable energy in microgrids, dependence on the conventional fossil fuel and centralized power plant is reduced now. Microgrids can attain a higher level of energy independence and resilience by producing electricity locally using solar power and wind turbines and other renewable sources, basically. Paper 3 was on reduced operational costs. So the added advantage is reduced operational cost. Over time, technology for renewable energy have gotten more efficient and cost effective nowadays. The next papers and multiple papers were there, which talks about, shall I present it like this, maybe? Yeah, can you see my full presentation now? Maybe. So e-mobility is one of the main aspects by incorporating EV batteries as mobile energy storage units and providing charging infrastructure. Microgrids can aid to the expansion of EV cars. This strategy can facilitate the switch to greener mobility while managing grid demand. So energy storage, so since we are talking about the energy storage equipments, there are various energy storage things that are coming up and there are in existence. So lithium ion batteries is one of them, which is very, very important nowadays. It comes with all the advances which have advantage of increased life cycle and environment sustainability also. There are other storage of ways of storing of the electricity, like various advancement in supercapacitors, energy storage flywheel, superconducting magnets, and compressed air also. There are other advancements that are there in progress research. So first case study I'll present, sir, on the vehicle to grid integration. This was this is there in the University of California. They have already done it during time of high demand. The microgrid powered the campus using solar panels and battery storage. Electric cars charging facility were also put in the place simultaneously all across the campus. These charging stations smartly used the batteries of EV as energy storage unit for the microgrid, and when they are plugged in. The microgrid use the EV batteries to balance the energy storage during the periods of high electricity demand or solar power surplus. In contrast, the microgrid prioritize EV charging when necessary based on the availability of renewable energy and grid circumstances. In addition to helping the institute achieve its sustainability goal, this V2G connection gave the EV owners a new source of income in exchange of their grid supplied energy service. This is very so this is the basically this is the architecture how we get power from solar energy and with the help of DC fast chargers we charge the batteries of the EVs. So the EVs can be charged from multiple renewable ways like solar panels which are there on the parking roof or rooftop terrace and various ways. So the proposed thing is to this is survey paper again. It is already there and in the research. So work is to charge the homes through vehicles, and this will be a bi-directional thing. We can charge vehicles also through solar, wind, or renewable energy, or with grid. And then, whenever required, we can charge back these homes also using our electric vehicles. So that's the concept. So and not only this, we can have those batteries utilized for various things like charging our homes or mobile tents or lift vehicles, things like that. Vehicle to home integration, as I told, sir, this will again enhance or take the things to the next level. This will power the household loads during blackouts or high tariff, or support renewable sources like solar by storing surplus energy and supplying it whenever needed. Reduce grid dependency. This is very important. So whenever we get power from grid, it has got there are areas where natural calamities, floods, or islands, they get very less energy from grid, or during the crisis they they have the blackouts. So this time we can have this batteries used for
Hello.
to power their homes.
Hello.
Ma'am, I'm on
Yes,
conclusion. I'm on
yes,
conclusion.
yes.
Microgrids have a variety of benefits to that make them important participants. Then microgrids are at the forefront of sustainable energy solution due to their capacity to integrate renewable energy sources, boost electrification and e-mobility, and improve catastrophe resilience. So it runs smoothly because of the seamless integration of innovative energy storage with technology, renewable energy sources, lowering carbon emissions and fostering energy independence. So, the future energy systems are likely to be increasingly decentralized, sustainable, and resilient. And microgrid technology develops and gain popularity in a variety of solutions, including industrial complexes and residential communities. Vehicle to everything is the next level now. Vehicle to everything integration as a flexible storage unit, powering homes, exporting to the grid, with EV load management, prioritization, EV charging, discharging based on demand, tariff, and grid signals. So we can have the EVs work as a source of energy. So basically, in California or US or Europe, they are using Tesla batteries, Tesla vehicle batteries, which are very they have got the good power storage capacity, and so that they can return back the power or give the backup to various things. These are the references. Thank you, sir. Thank you so much. I understand I have been able to complete this within time. Yeah, thank you so much. Sir,
Yes,
any questions?
really, it was a nice topic, and that is really helpful
Yes.
for the sustainable development.
Correct, sir.
So, I just want to ask in this regard, what is the role of smart grids and renewable energy sources that play in supporting the electric vehicle adaptation and charging infrastructure in a decentralized system?
Decentralized systems of smart grids are now made with AI, ML things, and IoT based systems, which are giving very reliable power. And it is making the grid very reliable by checking on the demand, the generation, and giving the advanced signals, advanced tripping signals. So it makes these smart grids system make the overall on grid system very reliable. Renewable energy sources again is an isolated thing which can be again integrated to smart grid to support in the times of high peak demands. This will go hand in hand in future, and with low carbon dioxide and low pollution and more sustainable solution to it. So.
Okay, thank you.
Thank you, sir. Thank you, host, and for giving me this opportunity. I am grateful to all you. Thank you. Thank you so much.
Thank you, sir, for your presentation. The next presenter is Shashank Patil from KLE Technological University. And the paper
Ma'am,
title.
excuse me, ma'am. This is Dr. Mohan.
Yes,
Can you give me a chance to present next because I need to go for another meeting. I'm right now in the US.
sir, can you tell me your paper title, please?
1 minute. Paper title is the pothole detection.
Sir,
Exactly.
are you one of the co-authors or are you the author? Because I don't have your
I'm
name
I'm
in my list.
I'm the main author. 3:30 is the presentation time.
Sir, we did not get, I don't have your name in the list of the presenters.
But this is the link they have sent me.
There might be some miscommunication. I'll get back to you in a few minutes. Meanwhile, we'll just
Sure.
have the next presenter.
Sure. Thank you. Sorry for the disturbance.
Okay, that's all right. So the next presenter is Shashank Patil. Sir, I request you to please start with your presentation.
Yeah, hello. Is my screen visible?
Yes, sir.
Yeah. Good afternoon, everyone. My name is Shashank Patil, and I'm from KLE Technological University. On behalf of my co-authors and my university, I'm honored to present a paper titled "Enhanced Slice-Aware Energy Optimization in 5G Networks Using Simplical Homology." So, in the next few minutes, we will explore a novel approach that uses advanced mathematics to address one of the most pressing issue in 5G deployment, that is massive energy consumption. But why focus on energy? Because 5G, for all its power, is facing a significant energy crisis. Let's look at the critical challenges. Massive power consumption. The network densification needed for 5G, with base stations deployed much closer together, leads to an exponential rise in energy use and multiple service requirements. The 5G networks has to simultaneously support high-speed broadband, ultra reliable low latency communication, and also massive IoT connectivity, each with conflicting demands. This leads to an environmental impact from an expanding carbon footprint and immense economic pressure on providers as energy costs also skyrocket. So the current statistics are staggering. Because 5G are projected to consume 3 to 4 times more energy than 4G networks. Energy already accounts for 20 to 40% of networks operational expenses, and this figure is also set to rise. This isn't just a technical challenge, but it's also a critical issue for sustainable and economic deployment. Yeah, so this leads to our central research question. How can we minimize energy consumption while guaranteeing service quality across all these diverse 5G applications? So to solve this, we moved beyond traditional graph theory, which often falls short in modeling the complex relationships in 5G networks. So instead, we turn to a powerful, a more newer method, which is called as cyclical homology. So this is an existing method. So what is cyclical homology? Let's learn a bit about its nomenclature. So think of it as a way to see the shape of network coverage. So zero simplices are individual base stations like dots on a map. One simplice are edges that appear when the coverage of two base stations overlap. Two simplices are triangles that form when three base stations have a common coverage area. Visually, I'll represent this in the further slides. This extends to a higher dimensions to capture even more complex multi-station intersections. The key insights come from analyzing the homologic groups of this structure. So so these are the different groups. Basically, there are two groups. The first homology group is H1, which identifies coverage gaps. So literally the holes in the network where service might be weak or non-existent, it is all represented in the H1 group. And the second and the other higher groups detect regions of redundant coverage areas where too many base stations are overlapping and presenting an opportunity to save energy within this group. Yeah. So let's start with a brief overview of our work. First, we introduced there is this mathematical approach. We tried and we applied the cyclical homology to the problem of 5G energy optimizations. We built a slice-aware framework. 5G isn't a one-size-fit-all network. Our system intelligently optimizes power for three core 5G service types. The first is EMBB, second is URLLC, and the third is MMTC. Balancing all these at the same time. So this enabled by real coverage modeling. Instead of using simple graphs, we represent the complex overlapping coverage areas of the base stations as higher dimensional mathematical structures. So giving us an much more accurate view of the network topology. And this model powers our this model helps us create this algorithm which works to minimize energy usage while guaranteeing that service quality never drops. So finally, we conducted the comprehensive validation. So our framework was rigorously tested in the MATLAB across 25 independent simulations runs to prove its effectiveness and its consistency. So the next, yeah, here's how we bring it all together in our optimization framework. So our mathematical formulation is straightforward. So we aim to minimize the total power consumption by deciding which base station to keep active, and this is done subject to the three critical QoS constraints which I had discussed earlier. Those are the MBB throughput, URLCC and MMTC. So the thing is, EMBB, we need to keep a check on EMBB's throughput, URLC's latency, and MMTC's capacity. So this is implemented via a topology-aware algorithm. So it uses the homology insight to identify redundancy base stations that are part of the higher dimension, and structures are flagged as candidates for power reduction. So simultaneously, it preserves critical nodes that are a part of H1 cycles, which we won't be touching upon a lot, as these are already essential for maintaining the boundaries of the coverage. It performs an iterative optimization, constantly balancing these two goals to find the sweet spot between the energy saving and service quality, and dynamically adapts. So the core challenge is to optimize energy while satisfying all three of these constraints at the same time. So yeah, so this is a visual representation of the symmetrical homology. What you are seeing here is a practical application of the 5G network planning. So each black dot represents a 5G antenna or base station, and the blue circles show their coverage radius. Essentially, how far each antenna can transmit, or it's all about the signal's effectiveness. So as in here, the zero simplex is like each individual antenna is a zero simplex. So it's a single point in our network topology. And the one simplex, which we had discussed earlier, those are the dash dots lines connect antennas whose coverage areas overlap, forming edges in our network graph. And the two simplex, the green filled triangle, represents a fully covered area where three antennas work together, creating what we call a two simplex. Yeah. So but here's the key insight. This area outlined in red with the dashed border, this is what we call a coverage hole, or a Betty one hole in topological terms. So this represents a gap in our network coverage, an area that's surrounded by antenna coverage but isn't actually covered. In 5G networks, this also means like it's a dead zone or potentially a network failure. So this is where our optimization comes into play, and we need to identify these topological holes using homological calculations, analyze the network structure to understand the why these gaps exist, and then optimize the antenna power levels and positioning to close these holes. So sorry, ensures so we ensure the entire area becomes what we call a two simplex fully covered.
Hello.
Yeah. Yeah.
So sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Yeah, sure. Coming to the results, so we are compared to with two different models. So we can see that 24.8% reduction compared to the baseline models, all by successfully meeting every quality of service constraint. When compared to other state-of-the-art methods, our approach is significantly more effective. Like energy-aware clustering achieves 12.3%, and the toposense reaches 17.6%. So our method surpasses both, and furthermore, uh, it has a least average time computation of just 83 seconds. It is more effective, efficient than the 134 seconds from the energy aware clustering, and 102 from the toposense. Yeah. Uh, we also analyze the frequency spectrum. The spectrogram shows a well distributed allocation of the power across the analyzed frequency bands. So our structured approach to frequency slot allocation minimizes inference and optimization. Most of the work of this is done from another project, and uh, it's a continued part of the previous project. Uh, Scalability, yeah. This is a very energy intensive solution, but yeah, we can reduce it by like further implementing a like selective triggering, a lightweight machine learning approach, and which detects significant changes in the network topology and triggers the homology analysis only when needed. Yeah, in conclusion, our research makes us several key contribution. We have implemented. Yes.
Huh?
Sorry.
Hello.
Yeah. Yes.
Yeah. Just I have found the result. Uh, I think the energy reduction, your method that reduce, that perform the better in energy reduction.
Yeah.
Yeah. So that is what 24.8%.
Yeah.
Correct. So at the
Yes.
same time, I just want to ask you, the performance of 5G services is getting degraded or not? Whether that type of the result that we have when the energy reduction is going on at the same time, the performance is increasing or decreasing?
Sorry, sir. We don't have that. I mean.
Yeah. Because that at the same time when you
Yes,
use
sir.
the
Yes.
any algorithm for the energy reduction, at the same time we have to also check whether
Yes.
the performance of our system is getting degraded or not, right? If
Yes,
it
sir. Yes.
is, if still it is stable, then we can use our algorithm for the energy reduction. If you have not performed that thing, then you can use as a future scope and also check the different performance parameters also along with it.
Okay, sir. I'll keep it in the.
Yeah.
We'll do it in the further implementation.
Yes, sir. Yes, sir.
Yeah. Thank you, sir.
Thank you.
Yeah. That's all. Thank you for your time and attention. Yeah, sorry. One second.
Thank you, sir, for your presentation. Now for the next presenter is Aditya Podar from PES University, and the paper title is Smart Agriculture and Next Gen Sustainability, Harnessing Big Data and Machine Learning for Carbon Sequestration Prediction with Blockchain-Powered Carbon Credit Trading. Sir, if you're there in the meeting, please start with your presentation.
Yeah, am I audible?
Yes.
Yes. So good evening, everyone. My name is Aditya Poddar, and I'm here today with my co-authors to present a research on smart agriculture and next-gen sustainability, harnessing big data and machine learning for carbon sequestration prediction with blockchain-powered carbon credit trading. In this research, we propose an innovative framework that combines advanced machine learning for precise carbon sequestration predictions with blockchain technology for transparent and secure carbon credit trading. So, next slide, please. Yeah. So, as we're all aware of the rising carbon dioxide levels in the atmosphere, it's driving global warming and extreme weather events, and it's resulting in significant biodiversity loss. Addressing this crisis demands a dual approach. So, we must reduce the emission but also actively try to remove the existing carbon dioxide from the atmosphere. This is where carbon sequestration emerges as a natural, scalable, and a promising solution. Soil possesses an immense capacity to store carbon dioxide through plants and organic matter, offering a pathway to mitigate climate changes. However, leveraging this potential faces significant challenges. Current methods for measuring soil carbons are often slow, costly, and they lack the scalability needed for widespread adoption. Remote sensing provides a broad coverage but can lack precision. This results in an unreliable data, making it incredibly difficult to accurately verify carbon credits. Furthermore, the carbon credit trading market itself is plagued by issues like fraud, double counting, and general lack of transparency. So then why did we go into the field of agriculture? Next slide. Yeah. Beyond the critical role of agriculture in food security, agriculture is a cornerstone for many economies, contributing significantly to the GDP and employment. More importantly, agricultural lands offset a presents a vast untapped potential for scalable carbon sequestration. By optimizing land management practices, we can transform farms into powerful carbon sinks, bridging ecological responsibilities with economical viability for farmers. So moving on to our proposed approach. Next slide, please. So our interdisciplinary approach integrates three core technological pillars, namely big data, machine learning, and blockchain. These work in sync to create a robust, scalable, and a transparent system. The first part, which is the big data pipeline, is designed for real-time data ingestion and management. Data is streamed into the Kafka topics, allowing for parallel processing by parallel processing by multiple machine learning models. This partitioning significantly reduces latency and enhances throughput, which is critical for real-time environment monitoring. Beyond speed, Kafka is also used for fault tolerance. Building on this is our machine learning module, designed for accurate carbon sequestration prediction. Carbon sequestration is inherently complex, influenced by a number of variables. Traditional methods are often slow, labor-intensive, and imprecise. Our system leverages the vast economic environment data to predict carbon sequestration using our trained machine learning models. The machine learning workflow begins with extensive dataset including parameters like soil type, bulk density, temperature, and other parameters. This data undergoes pre-processing involving feature engineering, correlation analysis, handling of missing values and outliers using techniques like the interquartile range method. We evaluated several algorithms, including random forest, support vector regressor, XGBoost, and recursive neural networks. Our selection process was guided by their performance in handling complex, high-dimensional datasets and their ability to generalize. We also used k-fold cross-validation and performance metrics like the root mean square and R-squared value to quantify prediction accuracy. The final element is our blockchain-enabled platform for carbon credit trading. Conventional carbon markets often suffer from the issue of transparency, verification, and trust. To overcome this, we employ blockchain technology. It's a decentralized and immutable ledger system to secure and verify each and every transaction. Within this framework, a permission network ensures that only authorized participants, such as the landowners, buyers, and regulatory bodies, can engage in trading. Trading is driven by supply and demand, with each transaction being immutably recorded on the blockchain ledger, providing an auditable and transparent record. Transparency is important for building trust and engaging wider adoption. Coming to our architectural design, this slide shows our architectural design. It starts with environmental data flowing in through Kafka producers. These send data to Kafka topics, which are in turn consumed by a machine learning pipeline. The model generates predictions, which triggers smart contracts on the blockchain. This issues carbon credits and facilitates secure trading, all recorded immutably and transparently. Moving on to our results, our machine learning model excelled with root mean square values ranging from 18.64 all the way down to 15.32 across various models including random forest, XGBoost, SVR, and recursive neural networks. Our best model hit 15.32 as root mean square value error for SOCMGHA, which stands for soil carbon content per milligram per hectare. For our R squared values, next slide, yeah, our R squared value showed like we could achieve the best value of 0.84, which means high accuracy. R square value stands for coefficient of determination. These metrics ensure reliable carbon credit allocation. On the blockchain front, our platform reduced cost by cutting down on intermediaries, making it accessible to small farmers. Transactions are secure, transparent, verifiable, so it fosters trust. Coming to the conclusion of our project, we developed an innovative framework integrating big data, machine learning, and blockchain technologies to address carbon sequestration and trading challenges. By leveraging real-time data processing, predictive analysis, and secure digital trading systems, the framework provides more reliable insights for effective land management strategies. Using Kafka for parallel data processing enhances the performance of machine learning models in carbon capture forecasting. The tokenization of carbon credits and smart contracts ensures secure and tamper-resistant trading, reducing fraud risks and improving trust amongst the participants. This scalable solution aligns with the global sustainability goals, benefiting both the environment and the economy. Thank you so much for your time. We are open for questions now.
Thank you, sir, for your presentation. Are there any questions?
Yes, I just want to, I have one question. What is actually the role of blockchain that is used here just for crediting the trading or anything else?
So the main role of blockchain here is one of them is to facilitate trading, but the other one is that the existing system for our carbon trading platform, which is present in India or maybe abroad also, it involves a lot of intermediaries, and in a big number of situations, the process is skewed, and there are middlemen who are taking a huge cut of the money which the farmers should get, and it's a very tedious process also. So
Yes,
yeah,
yeah,
to
that is
mitigate
okay.
all these, yeah.
Yeah, that is okay. Once the carbon, the credit is deposited in the wallet of farmers, right? So what will be the next thing? Yes, how they get the benefit of it, that credits?
Yes, sir. So basically, we also made like a POC for this, where the farmers as well as the industry people, they'll be given access to a Web3 enabled page. On that page, the farmers can go and exchange these credits for fiat currencies, which is basically money. So they will be transacting. They will be giving the carbon credits to the what do you say industry people who are trying to offset their carbon emissions, and in return they'll be getting paid in terms of money currency. We also have like the picture of our implementation, so we'll just show that to you.
Okay, fine, sir. I got actually what you want to say, right?
Yeah. Yes. Yeah. Thank you, sir.
Thank you.
Thank you, sir, for your presentation. Now we will go on to the next presenter. So the next presenter is Sanika Kalavade from Vishwakarma Institute of Technology, India. And the paper title is Smart Safety Surveillance, Deep Learning Based Detection of Drowning and Slipping. Ma'am, please start with your presentation.
Yeah. So is my screen visible?
Yes.
Good afternoon, everyone. I'm Sanika Kolole from VIT Pune. Our paper ID is 92 and title of our paper is Smart Safety Surveillance, Deep Learning Based Detection of Drowning and Slipping. Firstly, talking about the problem statement. The drowning and slipping causes lot of destruction, especially for children and senior citizens. Despite of various advancements in home safety, over 330 drowning incidents are reported each month. So there is a need for a real-time detection and alert system to prevent such incidences and reduce their consequences. So our objective is to build a real-time incident detection system which can replace manual surveillance with automated solution, which will be the user-friendly solution. Now moving on to the hardware and software requirements of our project. In hardware, we have used ESP32 CAM module for capturing the live feed from swimming pools and other areas. We have also used a buzzer for an alert. And in software requirements, we have used a YOLO V8 model and a Hugging Face for deploying our model. Further, for sending the notifications, we have used a Twilio software. Now let's see the methodology. We have installed the cameras in the required areas. So the thing is that we can install multiple cameras like near pool or in the house where elderly people are engaged, and that camera is connected to the centralized system for processing video feed and a buzzer for an alert. We have trained a YOLO model for sleeping and drowning detection. So basically in our model, there are 5 classes, namely normal class, drowning class, sleeping class, swimming, and a floundering class. So floundering is a state which is just before the drowning. Further, we have implemented a buzzer which will get activated upon incident detection, and alert message will be sent to a registered mobile number via Twilio. So, in the architecture diagram, we first found the live feed that is captured, and that live feed goes to the server. Then later we have used a Python script to capture the images from that live feed. There we are taking the screenshots from the live feed after every 4 seconds, and these screenshots will go to our YOLO model. This model will predict whether the condition in the image is normal or abnormal. If the condition in the image is abnormal, that is, there is any chance of slipping, drowning, or a floundering case, then the buzzer will get buzzed, and a safety message will be alerted on the mobile phone of the registered number via Twilio. This slide shows the validation performance of our trained YOLO V8 model for each class. We have mentioned the R value, that is recall, and the mean average precision. Overall accuracy of our model is 96%. Which was used to detect various human states such as drowning, slipping from surveillance footage. These matrices demonstrate that our YOLO V8 model is capable of real-time detection with high accuracy of safety critical events, making it ideal for deployment in swimming pools, industrial areas, or public safety zones. So, in conclusion, we can say that our system ensures real time detection of drowning and sleeping incidents using strategically placed cameras and the yellow V8 object detection model, which offers a proactive approach to accident prevention and enhancing safety in the critical areas. So, that's all from our side. Thank you. If there are any questions. Hello.
Thank you, ma'am, for your presentation. Are there any questions?
Okay, I just want to ask you, in this system, what you have used the deep learning, right, to improve the
Yeah.
accuracy, right?
Yeah.
So if you have compared these deep learning methods with some existing methods.
Actually, we compared only deep learning models, but from there are many YOLO versions. We have used 8 version, the latest version of YOLO. First, we compared the all versions from YOLO 1 to YOLO V8, and the version which gave us the best accuracy was YOLO V8. We have used that.
Okay, in your architecture that was shown, the message will be get on mobile, right?
Yeah.
Yeah. So yeah, there is alarm system alert on mobile phone.
Yeah, for that we
Okay.
have used Twilio software.
Right,
It
right.
is a
If your mobile in the net is not in the network, then still how actually the alert message will be sent?
So for that we have also implemented the buzzer system. So
Okay,
where
so for the buzzer system, we did not require any the network.
the buzzer system will buzz at the place where the incident have happened.
Okay,
So
okay.
the
So that is not
surrounding people
mobile.
near that incident can come to know that there is something fishy.
Okay, okay. So that will be the buzzer system is available in the car only.
Near the surrounding of where the CCTV camera is installed, from where we
Okay,
are getting the live feed at that place.
okay, fine.
Thank you, sir.
Thank you, ma'am, for your presentation. Now we will go on to the next presenter. A few minutes before, Mahadevan, your presentation was going on, and we just had to, it just got interrupted because of some network error. So if you're in a stable internet connection right now, you may continue with your presentation from where you left.
Okay.
Hello.
Yeah, I can.
So are you able to hear us?
Yeah, I can hear you.
Okay. So you can start screen sharing.
So the literature review. So these are some of the literature review that we have taken. First, we have the
Hello. Sir, please start your presentation from where you had left last time.
okay. So the literature review says about the first literature review is the excellence through diversity inclusiveness, a focus on IT industry, and the next one is the case study on diversity and inclusion of IT sector, a roadmap for organizational advancement. Next one is the diversity and inclusion key to improve productivity, a case study on Wipro. These are some of the case studies. So coming to the literature review, it says about this case study says about how these secondary data sources such as the IBF report, annual report, and from various companies and academic articles. This says that how this study identifies strategies for building a diverse workforce and examine how this DEI practices is happening in an organization. We know that in various organizations, DEI practice perspective also they will feel that nothing is working. But the company also says that DEI institutes are working in a good manner. But while we are getting interviewed from the employees, they are saying that they are not getting that much love. Next is the case study on diversity and inclusion of IT sector. It says that the study utilized secondary data sources including journal articles, newspapers, and business report. And it says about the study approach by Spoke. It says that strength, weakness, opportunities, and challenges. And companies like Infosys, IBM, and Accenture are some of those companies that we have taken the DA initiative that mainly focus on gender inclusivity, workplace accessibility, and post-cultural adaptability. So I think that these are some of those literature reviews that we have to understand. Next, it says about the case study on Wipro, diversity, inclusion, and key to improve the productivity. That is one of the most important literature review. It says about the Wipro DE initiatives, analyze their impact on organizational sustainability, and understand how this case study approach various secondary data such as journal articles, sustainability reports, and company disclosures. Next, coming to the research problem. So research problem says that mainly it aims to identify and analyze the alignment or misalignment between organization resources and employee experience. It says that from the employee side or from the company side, company says that even though they have taken various DA initiatives from their part, while we have taken while we are hearing the questionnaire also, we get a negative review from those employees. So that's one of the most research problems that we had in fact. And coming to the research objectives, it says that to analyze the representation of DA initiatives communicated through organizational websites, reports, and other published materials. Next, we have taken some of those companies from Great Place to Work, and this is a good website that's called a Great Place to Work, and we have taken around 20 companies. From that, we have taken best companies which is doing good DA initiatives. Some of those selected companies are Capgemini, Infosys, Wipro, Tech Mahindra, and all of those things. Next is the research methodology. The research design that we have used is descriptive, that is both qualitative and quantitative. And coming to the type of study, also we have used the descriptive method. While we have sent a questionnaire to those employees, like that we get a response from all those candidates. And the secondary data uses organization disclosures and employer review rating from different platforms. So we get an idea about how these DA initiatives have been implemented in various organizations, whether these employees are getting the benefit or sometimes lack of this DA initiative program will lead to employees left the organization. That's one of the main reasons. So coming to the thematic analysis part, our diversity and representation. Our diversity present at entry level fades at leadership. We know that while we are joining an organization, first we'll feel comfortable, but after sometimes we'll not feel like that. We'll not get that much engagement or will not get that much support from many of our coworkers. And next is the equity in career progression. It says that promotions are perceived both as merit-based and biased. And next is about the leadership. Leadership also play an important role. Lack of structured leadership. Leadership is something that is much important in an organization. So because of those various DA initiatives are not working properly, and gap in evaluating policy effectiveness on career growth. Next, it is about the inclusiveness in the workplace, like mixed employee experience. Employees from various backgrounds, they will not feel to speak in front of a large audience because they will not get a proper voice to speak. And next is the need for structural intervention for psychological safety. Next, it says about the DEI policies, varying DEI practice across organizations, especially the engagement, retention, growth, and the need for standard metrics, especially in an organization. Engagement activities must be there so that the employees also feel very much happy and the stress level also will be reduced. And some of the suggestions that we get from those employees that we interviewed are the awareness campaign and mentorship, like creating an awareness about those campaigns, giving a mentor, so that if there is any problem happen, an organization definitely will be able to speak and unbiased hiring. One next is need to access long-term impact on inclusivity and promotion. So these are some of the coding themes from the interview response that we have discussed before. First is the diversity and representation. Subtheme says that the gender
Sir,
diversity. Yes,
hello.
yes, sir.
So sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion part?
Sure. Yeah, sure. So coming to the findings that while we have interviewed employees, we get that the TA disclosures like through reports, through website, and especially through the employees' views, we understood that the TA initiative is not working in a proper manner. And coming to the conclusion part, there is a persistent disconnect between the DA discourses and especially the workplace reality. There is a misalignment between all those things and lack of implementation. Even though we give rules or we try to implement, norm is going behind that implementation. And as next is the need for leadership accountability and system changes. If sudden changes happen in an organization, we should be adaptable. We should know that what are the changes happening. Next is the emphasis on measurable impact, open communication, and feedback mechanism. If everyone is having a right to speak in an organization, definitely all those problems will be removed. And a proper feedback mechanism also will be helpful. Thank you. Hello?
Hello, I'm audible.
Yes, sir.
Yes, sir.
Okay. I just have one question. What kind of the what type of the discrepancy exists between the organizational DI narratives and their lived experiences of employees, particularly regarding inclusion, bias, and equity in career progression?
Can you repeat once more?
What type of the discrepancy that will be exist between the organizational DI narratives and the live experience of the employees, particularly regarding inclusion and bias and equity in career progression?
So, my point of view is that mainly the uh, uh, descriptive, like especially the men female wages. Sometimes they both work in an organization, they will not get the right salary, and some of those things like then some employees will be saying that gender equality. Even some organizations feel gender equality is one of the main thing. So I think these are some of the reasons behind.
Okay. Thank you, sir.
Thank you.
Thank you, sir, for your presentation. Now, all of the presentations are done, but there were a few absentees. I would like to call out their names for the last time if anyone has joined and would like to give their presentation. First is Riju Sundar from Rajalakshmi Engineering College. Is any of the co-authors present in the meet to present on his behalf? Okay, and the next one is Sohana R from Dayananda Sagar University. Are any of the co-authors present to give the presentation right now? Okay. So I'll just proceed with the closing remarks then. So I sincerely thank our authors for the excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD. I also would like to thank our session chair, Dr. Sopan Tadekar, for chairing this session. A token of appreciation to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable presence.
Thank you, madam.
Now, just before we end this session, I would like to request you all to please turn on your camera so that I can take a quick snapshot of today's conference. Okay, I've taken the snapshot. This was a great session. Now we can leave the meeting. Thank you, everyone.
Thank you.
Thank you.